I expect to see fully functional co-packaged prototypes from various providers in 2022. They may be disguised as pluggable solutions, but the guts of the electro-optic solution will be usable for co-packaged optics. There's an interesting dynamic where we're seeing solutions provided by module providers, that is, vendors selling EO solutions, and ASIC providers developing competing solutions. And I think the EO providers will get to the finish line sooner. This will probably drive some consolidation in 2023, and who buys whom will depend on who gets to the prototype finish line first.
Co-packaged optics is driving into that space to meet those demands. You'll see companies like Broadcom making new announcements for products in the co-packaged optics space, as well as groups like Kobo and OIF creating standardization that means that we'll have a robust marketplace for co-packaged optics moving into the future.
The 25.6T switches are getting deployed, and the interconnect speeds in optical modules have gone from 100 to 200, which would be in full deployment at certain data centers this year, and 400 gig, which would see even more widespread deployment within data centers. So in one axis, the interconnect speeds between switches within the data center does not show any sign of actually slowing down. There are discussions on 800 gig and 1.6 terabits per second, which will happen in full force this year as well.
I do expect that OSATs will also get onto the bandwagon of providing competing packaging solutions, competing and complete packaging solutions such as fiber attach and die attach. OSATs at this point have taken sort of a wait and see approach to see how the market develops, and the prototypes above will be a tipping point. I suspect that contract manufacturing model will become extremely challenged due to the complexity of packaging and the high capex.
With the faster growth in data usage in many different versions, will trigger different types of adoption in energy efficient data center infrastructures.
Based on publications from Nia Margalit of Broadcom and YK Chen of the DARPA Team Music program, where they've talked about what I term as sort of the Moore's law of photonics, and they talk about extremely high levels of integration possible with silicon photonics. And I expect to see some killer apps or killer performance in the area of photonic computing, which takes advantage of these high levels of integration. In this area, while we may not see fully baked silicon solutions, there will be sufficient proof points to indicate the viability of these solutions. The production viability of the microring modulators will be a key enabler towards this effort.
What technologies are needed to actually make all these need for interconnects happen? We can't just be increasing the speed of optical components. That alone is not going to work. So higher power DSPs, when I mean higher power, higher complexity DSPs that actually consume lower power, meaning designing at lower and lower CMOS nodes, higher bandwidth optical components. And above all, this year you'll see more and more deployment of highly integrated optical and electronic components.